Hello, everyone. Welcome back. So now let's talk about chapter 3.3, part 4, the fab number summary. The fab number summary of a data set consists of the following quantities, which is the minimum, the lowest value of the data set, and Q1, which is also P25, the 25th percentile. And then Q2, which is also the median, or we say the 50th percentile, P50. Or Q3, which is P75, the 75th percentile. And the last one, maximum, which is the highest value of the data set. So now we're gonna find the fab number summary for that old example, which is about the traffic violations. So we have calculated Q1 and Q3 for this data set, which is 22 and 15. So let's just write down Q1 equals 15, and then Q3 equals 22. So still, we're gonna just sort the data from the smallest to the largest. So we have 9, 12, 15, 16, we have 18, 19, we have 20, 22, 24, and 25. So 2, 4, 6, 8, 10. We have all the 10 values listed, and then we put those in increasing order. And we have our Q1, which is 15, and we have our Q3 calculated, which is 22. And then now we need the minimum. So minimum is the smallest number, so we can just circle this 9. That's our minimum. And then 25, that's our maximum. So now we just need the Q2. Since we have a total of 10 values, then we have 2 values in the middle to generate our Q2. So 1, 2, 3, 4, the 5th and the 6th. So these 2 values gonna tell us Q2 equals 18 plus 19 divided by 2, that's 18.5. So now we find all the 5 numbers we need for the fab number summary. Then let's write it down. The fab number summary is the minimum, Q1, Q2, Q3, and maximum. And the corresponding values are 9 for the minimum, 15 for Q1, 18.5 for Q2, 22 for Q3, and 25 for maximum. So this is when you answer this question, how to write down the fab number summary. And then part 5, let's talk about part 5, outliers. So outliers is an extremely high or an extremely low data value when compared with the rest of the data values. And for a data set, you should always check this outlier, because the outlier can stand far away from the majority of the group, and sometimes it might be because of a tap roll or some other error made when you record the data set. So if we look at this example, ages of students in a class, we have this 65, which is far away from the majority of the group. So we consider 65 as a potential outlier. And again, we want to mention this median and IQR, the interquartile range, are less affected by outliers. So they're called resistant statistics. So for this plot, we actually just see 65 is far away from the majority of the group, but just how to numerically calculate it, whether a value is outlier or not. Then we have this procedure for identifying outliers. We also call it 1.5 IQR rule. Step one, we're gonna arrange the data in order from the lowest to the largest, and then we're gonna find Q1 and Q3. After that, we can calculate our IQR interquartile range just by using Q3 minus Q1. And then step 3, we're going to compute the outlier boundaries. We call it the upper and lower outlier boundary. The lower one going to be 1.5 IQR distance lower than the first quartile, which is Q1. So we use Q1 minus 1.5 IQR. And the upper outlier boundary going to be from our third quartile. We want to look at another distance of 1.5 IQR above this Q3. Then we can make a range or interval so that we can check whether any value fall greater or lower than the boundaries or fall out of this interval. Then we consider those as outliers. So after discuss these 4 steps, we're going to look at this example. Check the following data set for outliers. We have 5, 6, 12, 13, 15, 18, 22, and 50. So for step 1, we're going to find our Q1 and Q3. Of course, put the data in an increasing order. So step 1. So since this is in an increasing order, then we don't have to do that. We just need to find our Q3 and Q1. So for Q3 and Q1, we're gonna look at the position first. Q3, 75th percentile. So we use 0.75 times the n. So for this data set, we have n equals 8. So 0.75 times 8. Which is 6. And then for Q1, we have 0.25 times 8, which is 2. And since they're all integer, then we're looking at the 6 and 7th value, the second and third value for Q1 or Q3. So the sixth order number is 1, 2, 3, 4, 5, 6, 18. And the 7th is 22. And then the second one is 6. The third one is 12. Then Q3 equals 18 plus 22 divided by 2. So which is 20. And Q1 equals 6 plus 12 divided by 2, which is, so that's going to be 9. So now we successfully find out our Q1 and Q3. And now we can move to step 2. The IQR equals Q3 minus Q1, which is 20 minus 9, which is 11. The interquartile range is 11. And at this step, we can actually calculate 1.5 IQR. Just use 1.5 times 9. That gives us 13.5. And then step 3, we can calculate the lower and upper outlier boundary. So for upper, we have Q3 plus 1.5 IQR, which is 20 plus 13.5, which is 33.5. And for, oops, let's move back to this one. For lower, we have Q1 minus 1.5 IQR. Which is 9 minus 13.5. That is negative 4.5. So this two boundary just make an interval so that we can check any number fall outside this interval. So after we look at the original data set, we have 50 lies outside of this interval. So 50 is more than even the upper boundary limit. So 50 is more than 33.5. So now we can say 50 is an outlier. And that's the step 4. Okay, so I'll finish this practice problem for identifying outlier using this 1.5 IQR rule. In 3.6, section 3.3 part 6, we're going to talk about box plots. A box plot is a graph that presents the 5-number summary. So we're going to learn something called a modified box plot. So for this way, after we draw the box plot, it's not actually the 5-number summary, but just something related with the 5-number summary and involving the 1.5 IQR rule. So this modified box plot can identify outliers. So these are the steps. We're gonna draw this box plot. Let's look at a practice just using those steps to construct the box plot. And this data set is for the TV viewing times. So we have a total of 20 values in this data set. And we can, just based on our procedure, we can calculate the 5-number summary. The minimum is 5, and the maximum is 66. We have Q1 equals 22, Q2 equals 30.5, Q3 equals 37.25. To draw this modified box plot, we also need the upper boundary and lower boundary for the outlier. So we have Q3 plus 1.5 IQR, which is 60.125. We have lower boundary, which is Q1 minus 1.5 IQR, and that equals negative 0.875. So this is the interval to identify any potential outlier. So when we draw the box plot, we just need this numerical scale representing the numerical values here horizontal wise, and then we draw a after this we're first going to draw this Q1. It's a relative long bar for Q1, Q2, Q3. So Q1 is 22, so we just need to locate this position which is representing 22. So I'll draw a little long bar here. So 22. 22. And then for Q2, it equals 30.5. So slightly larger than this 30. So 30.5. We got Q2. Q3 is 37.25. It's going to be in the middle of 35 and 40. So it's about this position. So 3 long bars. And then after that, we can connect these 3 long bars to a box. And then for this little 2 short bars, for this modified one, we want to look at the minimum maximum within the boundary, and then we call those adjacent values. So the minimum and maximum within boundary, we have 5 as the minimum within boundary, because the boundary is from negative 0.875 to 60.125. So 5 is the minimum within the boundary. and the maximum within the boundary is not the original maximum, because 666 is outside the boundary. So we're going to look at the next largest one, which is 41. 41. So we're just going to draw this 43, which is 43. So we're just going to draw this 43 here. So it's about right. So this is the 43 maximum within boundary. And then we connect this to a little bar to the box we just made, and then it is a complete box plot. But one last step, we're gonna just put a star here to represent the potential outlier. We only have one value, 66 is outside of this boundary. So put 66 here, representing it is an outlier. So that this one is a complete modified box plot. So after that, the last slide we're going to discuss is in this chapter is the box plot and skewness. So if you see a long tail which represent right skew, for the box plot you're also going to see a long line here. So it's very similar to the curved one. And then for this one, it's the symmetric and then left skewed. And again, we're gonna have worksheets 3 posted, and you can practice those problems. And then don't forget to turn in that worksheet 3 using the Blackboard submission link. And that's all for chapter 3. Thank you.